how many of you are available for a session if I take a session on your tomorrow morning, probably at EST, if I take it at Saturday 9 a.m. In IST it should be today Saturday again. Okay, maybe 9:30. How many of you are in for this? Because I thought of taking a session on Sunday also. So rather than taking a session on Sunday evening, what I'm planning is tonight. I mean, sorry, that means Saturday morning I'll take, and Saturday evening I'll take, and Sunday I'll give you all. Okay, 10 a.m. 10 a. I'll make it as 10 a.m. or something. That should be fine for me. This should be 10, 7:30. So Hamant is available, Mukesh is available. LT, send. I mean, oh, what were you asking? LT, I didn't get that. Lakan, everyone is available. Okay, what were you asking? Let me unmute you. Yeah.
I'm good for Saturday morning. Can we take Sunday instead of Saturday night?
Yeah, that's again. The thing is, I have two batches, right? I'm planning between both the batches. So, okay, what I'm planning to do is this batch I will take on Saturday morning, and next batch I'll take on Sunday morning, because next week I'm not there for your Thursday, Friday, and Saturday. 3 days I'll not be there. So before that, I will try to cover as much as possible. If something is left after I come back, right, I'm just going out of station. So after I come back, probably 1 or 2 sessions, whatever is pending, I'll take it then. So I'm planning to take it probably this week itself as much as possible.
The Sunday night is also okay, no problem.
Yeah,
Saturday
okay.
night.
Yeah,
that is
sure.
done. I can call it. It's not a problem.
Okay. Yeah. Thank you. For the people who has just joined, what I'm trying to do is, for the people, we will have tomorrow's session just like today's timing. But apart from that, I'm also planning to take a session on this timing. Like if you are in India, it is the evening 7:30 p.m. If we are in US, probably EST time zone, it should be at 10 a.m. Binoy, I see Binoy who has joined now, and is there anyone VNP? Are you available for this timings, both of you? Absolutely. Tomorrow you have two classes if you are in Saturday. You are in EST time. Yes, Binoy.
What time actually? EST?
EST it is 10 a.m.
10 a.m. 10 a.m. 4 weeks late.
Oh, 8. Okay.
11 actually. So you're evening, I'm right? You're
yeah, my evening, correct.
So that means, are you taking Saturday evening or Sunday evening?
No, Saturday evening also we'll have session. Saturday morning and Saturday evening.
Okay.
You are good, right? Sorry, Vinay, your voice is breaking.
No. For you today, it's Saturday morning today, am I right?
Yeah, see, you are in EST time zone, yeah?
No, I'm in CST center.
Yeah, CST it should be your probably 9 a.m. CST.
Okay.
Yeah. VNP, can you just probably adjust VNP for one day? Rest all are comfortable. Yeah. Thank you so much. Okay, let's get started, guys. Thanks, everyone. Okay, just to give a quick playback on what we have discussed so far, we were discussing about Spark, and what we have discussed was like we have discussed about the Spark architecture. We have discussed about what is this actions and transformations, what is an RDD, and how a Spark works, right? Up in what is this DAG means. All these things are something that we have discussed in our previous session, right? And now, I mean, we've discussed about what is this fault tolerance, how Spark is achieving fault tolerance, and we've discussed about, I mean, how this particular execution proceeds, right? And what is actions, what is transformations, what is this lazy evolution? All these details are something. Uh, uh, all these details are something that we have discussed in our previous session. Now, logical graph to execute, I mean, to physical execution plan. Like I already told, Spark will have a driver, which we also call it as a master. So he's the one who prepares the logical graph, like which RDD is present where, all these logical entities it will correct, right? And then it will prepare the execution plan. I mean, because see, a particular data node could have three or four blocks of a particular input that you are trying to process. So what it does is it has to execute four tasks in that particular data node. If your particular data node has only one block or one partition of your RTD, then it has to execute only one task. That's called the physical execution plan. First, the graph will be designed, and then the physical execution plan. See here, execution graph is broken into stages. Stages consist of multiple tasks. So I mean, it's simple, right? I mean, stage is something that I can easily assume. See, A to B is one stage, C to D to E is another stage, and it is broken into multiple tasks. I mean, each this particular stage is consisting of multiple tasks. See, the part this RDD partition, this particular part transforming into this particular part is called one task. Similarly, this is another task. This is another task. So this is a kind of each stage is broken into again multiple tasks, and I mean, again, see, each stage consists of multiple operations that can be pipelined. Like I told, this is another stage. Here, multiple operations from C to D is another one operation, and D to E is another operation. So that's what it means. A stage consists of multiple operations that can be pipelined, and stages are split when data needs to be shuffled. So here, a stage. I have this as one stage and this as another stage, and here your data has to be shuffled. When you are trying to join, your data needs to be shuffled, right? So that's when the stages got split, I should say. But you will understand more about shuffle and everything probably in our next slide. But a particular main program or a driver is someone who prepares the physical execution plan. The physical execution plan is something that it's broken into stages. Each stage consists of multiple tasks to be accomplished. A task is a unit of computation that can be scheduled on an executor. When you say an executor, is nothing but the data node. That's what all it means. Okay, a stage consists of multiple operations that can be pipelined. And next, see, shuffle means what? Redistribute the data among partitions. See, you've seen about shuffling in MapReduce, right? It is very much similar to that. Shuffling is what in MapReduce? When I have a map producing the output, right? When I have the map producing the output, this particular uh, data will go and sit in your in-memory key value buffer. And then what happens is you'll generate the spill files. And the spill files will be already partitioned. What you do is you do the sort and you shuffle it across a reduce, right? That's what happens in MapReduce shuffle. Even here, when you are trying to join two data sets, what happens is you have to take the two data sets and here a particular common data sets has to be brought to another RDB, brought as another RDB so that further operations can happen. Shuffling is nothing but I mean taking the data from one data node to another data node and I mean clubbing it. It's mixing it. So if that happens with reduce operator, group by, or join, it is similar to your map reduce shuffle. But the difference, that you find with respect to shuffle in Spark is it entails writes to disk. What does that mean is, it doesn't always do operations on top of disk. As and when required, it utilizes disk, or else it will be happy with in-memory. That means, like I told, MapReduce is primarily dependent on only on disk, whereas Spark will utilize your in-memory to whatever extent it is possible, and only when it is required, it will be going with disk. Because if something is not fit into in-memory, that's when it goes to your disk. Until then, Spark utilizes in-memory. That's what it means. Shuffle entails writes to disk. It utilizes disk only when it is required. That's what all it means. Shuffling is nothing but when I have to group data together, that's when shuffle happens. Okay. So that's the major difference between your MapReduce and your Spark again. So lineage and fault tolerance. So lineage is something like, see, if I have an RDD, right, and RDD is nothing but it's an abstraction of a data set that is split into multiple partitions, right? So one of the partition misses. Let's say here a red colored partition is missing here. Is it like the entire RDD B has to be calculated? I would say no. This entire RDD B need not be calculated. Whatever missing partition is there, your Spark knows how it has to be rebuilt. It will rebuild it. Because maybe, let's say, this particular A, which is there in data node 5, right? Data node 5 is lost. This particular partition is missing. But the whole RDD is not missing, right? I mean, I have other two partitions for this particular RDD. That's fine. You are not bothered about other two partitions. What you would be doing is you would be recalculating this particular partition array. That's what a lineage means. Lineage means the process of calculating the missing data without disturbing other process. I'm not even disturbing my other partitions of RDD. Only the missing partition I'm recalculating. Because RDD is what? It's an abstraction. It tells how a particular RDD can be converted into another RDD. So it has that logic. So it will execute that logic and constructs this particular partition called P. That's the whole story behind your PEs. With this, I think we are done with the theoretical discussion of Spark, right? I spoke about the architecture, I spoke about how it works, I spoke about the lineage, I spoke about the actions and transformations, right? You should get a firm understanding of how Spark is and why it is running 100 times faster than MapReduce, right? And why people are going more for it. Because if I wanted to query some file, right? I mean, I'll tell you what all functionalities we are going to discuss on top of Spark, then you'll get a better picture. See, what happens is, for example, if I have a file, I wanted to transform it, I would use Spark, right? I have a file, I wanted to transform, apply some series of transformations, I would use Spark. I have a file already structured, I wanted to do some analytics on top of it, I would use data frames of Spark, right? Whatever be the format, I would like to use, and I would like to run some analytics on top of it. When I have a file, when I wanted to run some analytics, right? It's more like I wanted to have some file in the format of a table. That's when I would happily go and apply some analytics on top of it. So that's what I'm trying to do here. I'm trying to run some analytics that is using data frames. I have a table, maybe in SQL or in Hive. We'll primarily go with Hive. I wanted to run some analytics on top of it. I would be using Hive context for this. When I have to run some analytics on top of an SQL or on top of Hive, which I mean, tables are already existing, and then use Hive context, right? Or I have some data coming from Kafka. I have to do some streaming. I mean, this is related to streaming of your data. I would be using Spark streaming. So that means I'm able to do a lot of things using Spark. That's why Spark is so much popular. It's not just about only streaming. I have some data. I have to do some machine learning on top of it, right? you can still use Spark for it. Spark Emily. So the Spark has a lot of functionalities here. Spark can be used, a normal API can be used. You can use Spark data frames. You can make use of Spark Hive context or SQL context. You can make use of Spark streaming. You make use of Spark Emulate. So all these, I mean, apart from machine learning, I would be covering all these particular functionalities, right? How it works and where you are using and everything. That should give you a better picture on how Spark is working. Okay. Yeah. So, given this particular briefing, I'm proceeding further with the practical aspects of Spark. You have any questions on whatever we discussed so far before we proceed any further? Is everyone good? Yes, yes, go ahead, please.
You said the Kafka streaming. What is that streaming file? Is it video file or IVR file something?
No, it can be some data. I mean, we did not. For example, you continuously get the data every second or something, right? Every second, your source is giving the data. You are streaming through that particular source, and I mean maybe through Kafka, and you are getting the data and putting it into HDFS. That's what called as a stream, and Spark is capable of doing that as well.
What is it Kafka you said? Is it getting data continuously?
Yeah, it's a messaging broker. Kafka is a messaging broker.
Message broker. Okay.
Yeah. Okay. I mean, you will understand how streaming works after discussing about Kafka.
Yeah, we know message broker. I know message broker we are using. Okay.
So, as I don't see any further questions, I'm proceeding further with the Spark practical part. Again, I'm gonna send a case study that correlates both Hive and Scoop, which I'll be sending it after the session today, right? Close unwanted terminals. So I'll have two terminals, one for Spark. So like I told, Spark applications can be developed using three programming languages, let it be Java or Python or Scala. Scala is the most preferred, but again, I don't want it to make you learn a new programming language altogether. But again, nowadays Python is also very heavily used for your Spark application development because Spark doesn't have any language barrier for developing components, right? So I would simply type PySpark, which will take me to the PySpark shell. Right? Initially, we'll try to do some exploration using the PySpark shell, and then I'll tell you how to write some Spark applications, right? Like to execute them, just like we have written some HQL codes, right? Just like that, how to write Spark applications. I'll tell you probably after we get some basic overview on Spark commands. Okay. Now that I've logged into Spark shell, if you could see that Spark, the version being used here is 1.5, and see here the Spark current version, stable version is 1.6, right? And the binary version available now is 1.7, I guess. But 1.5 has all the missing properties that were there in earlier versions that are missing. Everything. Okay, so Python that we are using here is 2.6. So now what I would like to do is I would like to show you some basic things on how we work on Spark and stuff. For example, let's take a particular input data set, right? I will name it, the word count data set we have taken, right? We will take that particular data set wc input.txt, right? This is the input I wanted to take. And what I would like to do is, I would like to create a directory under user Cloudera batch 26. I would like to create a Spark datasets or something. I will put it as, and I would like to put this input dataset into HDFS. Right. So I have my data set present in two places. One is in my local file system, another thing is in my HDFS. I'll tell you how to load data from both the things. One is from local file system and another is from HDFS. What did I tell you? When you are developing any components on Spark, the first entry point of Spark is Spark context, right? So Spark context available as SC, and Hive context is available as SQL context, something like this they have given. But anyways, now that I'm trying to do some analytics, transformations on top of a file. So what I would like to do is, I would like to use a Spark context which is available as SC. Now, what I'll do is, I'll try to name my input already as input equal to SC dot. What am I trying to load? I'm trying to load some text file. So I'll use text file. If I wanted to load the data from HDFS, HDFS colon forward slash, right? And then your path, where is this? Yeah. Paste. So yeah. What I've done is, I've loaded the particular text file which is there in your HDFS. So if I wanted to see what I've loaded, so input dot collect. Collect is nothing but select star from your table. It should give you all the details, like all the data that you have taken. So yeah, it gave me the output here. Yeah. But see here, you can ask me, hey, why is it including everything in U and a single quotes? Why is it not giving me in the way that it is present in the file? Spark by default produces the output in a Unicode format, right? This is the Unicode denotation. If you want to change it to a plain format, you can do that. Probably I'll show that when we actually work on Spark applications. Okay. So now what did I do? I've loaded an input data set, and then I've used input.collect. When I used input.collect, immediately some execution had happened. That means collect is an action with respect to Spark. That's why execution has started. One has to remember that. And if I wanted to load a file which is there in my local file system, it's simple. You can straightforward use it with file of, file of, and then your path. What's the path that and the input file name is wc input.txt, right? wc input.txt. So even this will load the data into your dataset, but only difference I've made is I've used file in place of my HDFS. If my file is present in my local file system, I would use it simply a file rather than HDFS column. So that's the only difference between loading a file from HDFS and loading a file from local file system. Okay. Now I've loaded a file. Now what I wanted to do is, I wanted to let's see this file. Okay, I should have done something like, I'll put some empty spaces, right? Empty lines I've put here in this particular wc input.txt in local file system. Here 50 lines are there. Out of that, 3 or 4 are spaces and just empty lines. Now what I'll do is, I'll just try to load the file from my local file system, and then I wanted to see how many lines are there. Input.count. I'll simply type input.count. which should give me 15 lines. Now, what I wanted to do is, I wanted to filter out only the non-empty lines. Empty lines I will have to eliminate. So non-empty, something like this. I'm just, any generic name you can give. What I'm trying to do is, I'm trying to apply a filter on top of your input RGB. Input dot filter, right? Input dot filter. What I'm trying to do is, I'm trying to use a lambda. I hope you have gone through lambda operator in Python discussion that I've sent. I mean, in Python videos I've sent the Python videos that I've sent to it will have some detailed explanation about lambda. But just to give you a brief note, lambda is a functionality that is available in programming languages like Python and Java, which eliminates of writing the functions in Python. I mean, for example, I have to write some functions. I don't want to write functions again. Every time writing functions is it's a tedious task. Rather than writing functions, I would like to achieve that using a simple one-line statement. Till lambda of x, right? What I'm trying to do is, I'm trying to find length of only, I'm just trying to filter out only the length greater than 0, length of x greater than 0. That means what I'm trying to do is, every line will be going to x. If it is greater than 0, length is greater than 0, only then it comes to this non-empty array. So see here, non-empty dot count. It should be somewhere between 13 or 12 See here, 12. That means there are 3 empty lines present in here. So, but see here, there is a difference. When I typed this, Spark didn't execute at all. But when I typed count, it immediately executed. So that's the difference. What happens is, filter here is a transformation, and count here is an action. Transformation is what? Generating a new RDD out of an RDD is called a transformation. That means I'm taking an RDD called input, I'm filtering the lines that are having length greater than 0 and storing it in non-empty RDD, which is nothing but applying a transformation on existing RDD. When I apply a transformation and I am taking some count is what? It is actually acting on the RDD and giving you the results. So count in non-empty dot count should give you the output something like 12. So that says everything, right? So operating on top of an RDD is called an action. So count is an action, or a collect is an action, which gives you the output, right? Which gives you the output after execution. So this is what called as a lazy evaluation. This is the best example I can tell you. Right? When I have a transformation, there is no execution. When there is an action, there is an immediate execution. So let me just play back what we have discussed so far. I have loaded an input file, and then I filtered the non-empty lines. Now, what I wanted to do is, I wanted to do an word count on top of this data set. First, what did we do in our MapReduce? What we have done is, in MapReduce, we took every line and we broke that into words, and then we took all the words, right, and then we took every word and we produced as word comma 1, and then we have applied a reduce operator which gives word comma count. This is what we have done in word count. So we are taking every line and breaking them into words. Now what I'm going to do is, the same thing I'm going to do in Spark as well, right? What I'll do is, I'll do the same thing in Spark, but I'll tell you what all functionalities I'll be using. For breaking, rather than breaking line by line, I'll just change this to, I'll break entire data set into words, right? That means this entire thing I've done in map or logic, right? I will be using a function called flat map. For this, breaking entire data set into words based on some delimiter, I'm using flat map. And then I will, to produce word comma one, I'll use map. And produce this particular word comma count, I will use reduce by key. So these are the functions that I'm going to use. I mean, what are these? These are again transformations, because this is an RTD, I'm producing another RTD. This is an RTD, I'm producing another RTD. And this is again internal RTD, and this is producing another RTD. So all these are your transformations, right? I'm transforming one RTD to another RTD. But what is the difference between a flat map and a map? That's the important question that you are supposed to be understanding, because that's the most frequently asked question. Both map and flat map works in a similar way. I mean, when I say similar way, it takes an RTD and produces a new RTD out of it. Okay, both map and flat map produces same thing. I mean, takes an RTD and produces a new RTD. That's why they are referred as a transformation. Hope you understand it. But what's the difference? Flat map works with entire data set. For example, I'm trying to take a data set and break them into words. So what it does is, it takes the data set and flattens it. I mean, it applies the logic, whatever you're trying to do, and it flattens the data set. It's not going to emit record by record. Rather, it's going to give you entire data set. But no, my job is to some logic, record by record. Because every word I have to take, and I have to give word comma one. That's when I'll go with map. So simple. Map works on every individual record. Flat map works on an entire RD, and it flattens it. So that's the difference. If your logic is to have an operation work on top of a single record by record, I mean every record by record, then you'll go with map. Now my job is to apply entire thing, I mean a logic on an entire data set, not record by record. Then you'll go with flat map. The classical example is this thing. I can happily convert my entire data set into words. But when it comes to word comma one mapping, every word I have to take and I have to map it with one. So this kind of scenarios differentiates map and flat map. Okay, so when I have to operate on a whole data set, I will go with flat map. In a data set, if I have to operate on top of record by record, I'll go with map. Reduce by key, you already know. I'll have a key. Based on that, I will be reducing. Yeah, based on that, I'll be reducing the count, and it will give you the count. So similar to what you've done on top of your map reduce. This invokes shuffle. You know, shuffle entails writing into disk with respect to Spark. So most of the cases it doesn't go to disk. It does everything on top of it. Clear so far? So that I will show that how it works practically. Everyone. See, when I say PySpark, we are doing all the commands and programs on top of Python. You simply type Spark, it takes you to the Scala. Okay, PySpark is a Python Spark. A simple Spark is a Scala Spark. Okay, you have to understand the difference. So, is everyone clear, guys, or any questions? Can I proceed further? Can everyone confirm? Yes, Lakan, please go ahead.
Yes, Surya. Hello? Can you hear me?
Yeah, please go ahead.
If an RDD is created and we have used it to do some transformations, and then we got some final result, and if at all, if we want to recall the RDD which we created in the first, how can we recall all those RDDs which have been created?
I mean, recall in the sense you are trying to create the same thing again, or you wanted to change it?
Yeah, actually, the same RDD if you want to use it after doing some transformations.
Yeah, you can use it as long as you have it. See,
where does it store? I mean, like, where does it store? How do we take it?
It entails simple logic is it entails writing it into disk. If it is required to be written into disk, it does that. But see, unless you specify, hey, if a particular RDD is generated, for example, you have an RDD called non-empty. I've generated that. I wanted to store that on top of disk. Then you have to specify that explicitly. Else, it's gonna store it on top of in memory only.
Yeah, but if it is stored in memory, like we don't remember the name set, the RDD name what we created. So how do we write down?
We will write the program, right? Everything will be there in a program, so it will automatically remember. I mean, you know what you are creating. See, unless you know something, for example, what you are saying is, I've created some program, I've used some variables, I don't know what variable I've used. But when you don't know what variable you've used, how will you tell program to give you the output? So you have to know what your RDD name is, and you will not forget that because you will put that in a program. Not, I mean, you are not. Now that I'm showing it in a shell, later, I mean, after executing this, I'm gonna show how it can be executed on top of a particular program. Then it will give you the name.
So you'll be writing everything, all those RDD names and everything in some application you build, right?
It's like a program that we are doing.
So we gotta remember the RDDs names.
Yes, obviously.
Okay, but if we have like so many RDDs, like how do we do with that?
It's simple, like you'll understand that when it's writing a program with variables. Right? When I have too many variables, I have to know which variable I wanted to use. I mean, as simple as that. I mean, you can just simply correlate this with the programming language with the variables.
Right? Okay. 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 Yeah. Thanks.
You'll get a good picture when we are trying to write some applications on top of Spark. Yes, LT, go ahead.
Yeah. What is it? How to go into the PySpark? We have to say just PYSPARK? The local host?
Absolutely, that's correct. You have to press enter and it will take you to the PySpark.
You choose command not found. Do I have to go anywhere?
Or in CDHD you are trying to do?
Yeah.
Yeah, you have to do this. I mean, I forgot to tell you one more thing. Spark works only on top of YARN. Am I correct? Because Spark is on this application. CDH3 is 1.2 architecture. You have to download the CDH5. I would preferably recommend you to go and download CDH 5.5 and then start using Spark. But again, there is a constraint here. If at all you wanted to use CDH 5.5, you should have minimum of 8 GB. 8 GB RAM is something that you're supposed to have. See, if you are trying, I mean, if at all any one of you are having 4 GB RAMs or something, if you wanted to upgrade, I would recommend you to upgrade to 16 GB RAM rather than going to 8 GB RAM. See, I can happily sit and practice whatever I want with a 16 GB RAM without bothering about, hey, why is it getting slowed up, or I need not to have all this headache. Have a 16 GB RAM laptop and you can, you need not bother about anything and happily work on it. Okay.
So in CDH3 I cannot use it.
You cannot use Spark on CDH3. As simple as it's a 1.4 architecture. As simple as that.
Yeah, I have Hue at my work. We have just installed. If it is in Hue, how to go there?
Okay.
Is it different?
No, it's simple. I mean, when you are using Hue, right?
Yeah.
First thing, do you have Spark editor here?
Yes.
You don't have a Spark editor, right?
Yeah, no Spark editor.
That means, that's why I wondered. I mean, if the latest version of Hue is coming up with Spark, so Hue doesn't offer you a Spark, so we cannot do anything on top of Hue with respect to Spark.
Okay. Okay, so I have Hue at my work. I thought I can use that. Okay, then that's fine. I'll find out how I can use Spark.
Sure.
Thank you.
Now, going back to the terminal, I filtered out the non-empty lines. So now, what I would like to do is, like I told, I would like to break the non-empty RDD into words Let me name it as words. Words equal to non-empty dot flat map. Right, again I'll use lambda x of x dot split. I mean, split usually works with the comma separator, right? That's fine. So what I'm trying to do is I'm trying to split an non-empty RDD into words. See here again execution didn't happen. Simply, I mean, if I give something like a flat map one or something, some syntactical issues I will deduce, then it will tell you, hey, this is not existing. That means it's gonna validate whatever you're typing, but it's not gonna execute it. Okay, and it gets executed only when, and you have seen collect and count, right? Let me take another thing. Take of two. It's like select star from a table, limit two. It's again an action. Here again it's getting executed now. Take of two will give you two results. Here hello world. Now my data is getting split into words after I wrote flat map. Now what I wanted to do is I would like to create another RDT called words map or something. What I would like to do is words dot map of lambda x of x comma 1. That's what I wanted to do, right? I wanted to give, I wanted to take every word and produce it as word comma 1. So words map take of 2, there you go. Every word it is taking and it is giving you as word comma of 1, right? So let's play back what we have done so far. Just wanted to show you how things work. Input RDD I have created, and then what I've done is I've filtered the non-empty lines, and then when after I filtered the non-empty lines, I've done a flat map, breaking that into words. I've done a mapping of word comma 1. Now finally, I have to have final OP or something, final output, which is like words map dot reduce by key, reduce by key, again lambda I use. You can ask me, hey, what if I don't want to use lambda? You can write a function. How to write functions I'm going to show you probably after a little while. Right? So this is something. It is clearing off the cache memory, that's why it is going. So I'll just take x comma y, right? What I'm trying to do is I'm trying to take two vectors x comma y, and whatever comes to x and y I'll simply do a sum of it. Okay, don't get confused with this. What I've done is I'm trying to I'm trying to take I'm trying to take every word, group it by key. So if I have hello, all the hellos will be grouped, and its values goes to two vectors x comma y. If I have 1 million vectors or something, first 0.5 million goes to one vector, another 0.5 goes to another vector called y, and they will be summed up. And now I've got the final output. Now if I want to see all the entire output, final op dot collect. Collect is like select star. Okay. There you go. I've got A's to real to B's to all this got sorted. So all this got reduced by key, and you are getting a final output. But this is not a sorted output, right? What I see is it's a jumbled output. So I never told you that sorting happens by default in Spark just like MapReduce, right? So that's what happens here. What you have to do is sort by key. If you want to sort it by based on key, you simply enable sort by key. Okay, and now if I use this thing here, now it got sorted based on your ASCII value. All the uppercase letters got sorted, and you're able to see that, and then the lowercase got sorted, and you're able to see that. What I've done is sort by key equal to is something I've made it to true. That's why I'm able to sort the data. As simple as that. Okay. So any questions here so far before I proceed further? Okay, let me just. Okay, there are a few questions now. Mukul,
You did.
please go ahead.
Surya, I didn't understand the use of two vectors x and x plus y. Why did you
Use okay. I'll tell you, sir. See, reduce by key, and that's again. I've told you how internally it works. You can you just blindly remember it as something like an syntax. Just like for map, how I'm passing lambda x, flat map, how I'm passing lambda x or something. For flat map, you have sorry, for reduce by key, you have to pass x comma y. So I mean, people will ask why, what is this x and what is this y? What you are trying to do here, reduce by key. For example, you have got hello, and you have got probably 1,000 values to it. So what does reduce by key has to do? It has to sum up all these values, maybe 1 plus 1 plus 1,000 times, it should give you 1,000. When it is doing sum, right, reduce by key, maybe the first 500 values goes to a vector called x, next 500 values goes to a vector called y. Those vectors will be internally summed up, and then these two final vectors will be summed up, which will give me x plus y. That's how reduce by key internally works. But x comma y, why did I pass? It's a syntax. As simple as that. Got that, Niku?
yeah? So x plus y, I mean, so it's kind of two reducers, right?
It's like two vectors of values that every key is getting.
Okay.
It's not two reducer.
Okay. Yeah. Thank
Okay. Yeah. You can take it that way, sir. Yeah. Two reducers also when you compare it with MapReduce.
Okay.
You did.
Just don't go into the internals of it. Understand that it's a syntax. Just for your awareness, I told you that it is x comma y are two vectors which holds the values. Yes, Mukesh, please go ahead.
That was the same question that I didn't understand the point, but you just explained it.
Okay, cool. Lakshmi, you can start practicing the things. What you can do is rather than waiting for the installation, you can straightforward upload the CDH3. I already told, right? CDH3 VM image I've already sent. It's an 8 GB file. You download it, upload it into your VM workstation, and start working on it so that it works fine. Okay. And okay. I will give you a case study to work on before. Okay, for the people who have just joined today, I mean just little late. You have to see that there is another session happening tomorrow morning. That means if you are in a EST time zone, you are going to have a session at 10 a.m. Saturday. That means tomorrow morning, as well as our regular timing. We will have one more session. If you guys are in IST, please do remember that you are going to have a session today evening and tomorrow morning as usual at our regular time. So that means you are going to have two sessions, one on tomorrow morning and one on tomorrow evening if you are in EST. If you are in IST, today evening you are going to have one session and tomorrow morning as usual we'll have another session. Right? So this will be the timings for the people who have just joined. And yeah, coming back to the case study that you are supposed to work, I'll give you a data set something like this. ABC, CDE and 1, comma 1. Okay, whatever it is. EFG, GHI, comma 2. So what I would like to do is, this is a comma separated input, let's say. Using Spark, you load this data set, or what are the steps you have to do? Load the above data set into Spark. And what you are supposed to do is, split every line based on comma separator. Simple thing I wanted you to do. Right, so that you are getting the flavor of Spark, how Spark works. So what you're supposed to do is, you're supposed to load the input data set and split it based on comma separator. That's what all you have to do. Right? And again, apart from this, I'm gonna send you another case study which is a combination of Hive and Scoop. Please work on it. It gives you a better picture how Hive and Scoop always travel together. Majority of the cases, they always travel together. How? You'll understand after working on that particular case. When we come back tomorrow, tomorrow morning, that means today Indian evening, the first thing, now that I can little fasten up the Spark practical things, because I've just introduced you with the Spark shell. Now I have to tell you how Spark programs will be executed. Maybe I'll talk about the joins. Now that I spoke about how collect, count, take, actions like take will work, and you can also look at how another okay. Now I got the final output, right? If I wanted to save it, maybe save as text file or something, right? Save as text file. What I would like to do is hdfs :// user cloudera batch 26 spark op1 or something you can use, which will be a directory. So it wrote the output. Now I should see some output in spark op1. The same output to whatever you got on your command line should be seen here. There you go. So it got created in two output files. Right? There you go. Okay. So similarly, save as text file is another action that you have on top of Spark. All these are actions. With respect to transformations, you understood about map, flat map, filter, reduce by key, right? So all these are the transformations we have learned. So we will learn few more transformations like map with partitions, right? And I'm going to talk about interesting few more transformations which we would be applying on day-to-day basis, right? And then I'm going to show you how to apply Spark on top of how to write Spark applications, and then we will be talking about the data frames using Spark, right? When I talk about all the basics of Spark, then I'll proceed to the next level, data frames using Spark, and then I'll proceed to another level using the Hive context. How do we use Hive context? But this Kafka part, right, I will introduce after introducing you with Kafka. The streaming part of Spark, I will talk about after talking with about Spark, Kafka. So someone can remind me during the after the Kafka session. I'm gonna talk about how Spark works with streaming. So this discussion will take another 2 days of time to complete all the things. This should complete all the things that you do with Spark in real time. When I talk about all these things, you should definitely understand how things work in real time using Spark. So I would like to give you some case studies on top of Spark as well, right? So for today, you just work on a simple case study of Spark and provide me the output, and also I'll be sending you the case study on Hive and Scoop, right? So let's come back on tomorrow morning at 10 a.m. IST, 10 a.m. EST or 7:30 p.m. IST. Okay. So that's it for now, guys. Probably, Binoy, I will respond to your email, Binoy. I'll specify the timings there in the email. Okay. So thanks everyone. Bye bye and good night.